6, 7, exponential growth and exponential decay. Okay, so that's all about our B value. That's all about our graphs. Now, what we're going to do right now is super easy. We are going to literally look at an equation. We're going to figure out these two things. Identify the initial value and the growth/decay factor. The initial value is like my y-intercept. That's the A value. The growth or decay factor is my B value. So when I say, what is A equal to in letter A, what do we say? It's 12. What is B equal to? So then, is this growth or decay? Why do we know it's decay? The B value is less than 1. Fantastic. Okay, let's do another one. Letter B. A equals 1/2. B equals 6/5. Growth or decay? Why? It's bigger than 1. What about letter C? A equals? B equals? Growth or decay? This one is growth. It's bigger than 1. Letter D. A equals 1/3. Thank you. B equals? Growth or decay? Beautiful. Any questions on that? That's the easiest it gets. Turn it over. Great. So, I'm going to make it a little bit more challenging for you, just a little bit. Let's think about our original equation, y equals a times b to the x power. Well, we don't always just want a b value. A lot of the times when we're talking about the data that is used in these functions, like we usually use this in some kind of data collection, we're talking about rates, and we like rates as percents. So we kind of change our formula around just a little bit to kind of show the rate. These are two basically of the same equation. I didn't change anything. This thing in parentheses here is the b value. Our b value, if it is above 1, we're basically saying how much further than 100% did I grow. So it is 100% plus something else. That's meaning I'm growing by some kind of rate. It's above 1. If it's decay, I'm saying how far under 100% am I? 1 minus this rate. That's our b value. The baseline is always 1. How much more than 1? How much less than 1? That is growth or decay. Okay? So the thing that we're looking at in here, it's always going to be 1 plus or 1 minus. The important part is this R value. R is rate. R is a growth rate or a decay rate, depending on whether you have plus R or minus R. Okay, so the difference in these problems, if we take a look, it says determine if the function represents growth or decay. We're going to do that the same way by looking at the b value. Then we're going to identify the initial value, which of course is our a value. And then it says, and the rate of growth or decay, not the growth/decay factor. If you ever see the words growth/decay factor, that's talking about the b value. But if you see rate of growth or decay, it's asking for the r value. It is very important that you know the difference from when it's asking for b, the factor, or r, the rate. Is that clear? Okay. So, first 3, very straightforward. If I take a look at A, I have y equals 1200 times 1 plus 0.03 to the x power. Is that going to be growth or decay? It's going to be growth. If we think about this entire bubble as the b value, that b value is going to be bigger than 1. So we know that that's going to be growth. My initial value A has not changed. It's 1200. But now I'm being asked for the rate instead of the growth/decay factor. The rate is not including the 1. It is just this guy right here. So the rate is 0.3, and it asks us to give that as a percent. So I need to convert that decimal into into a percent, how do I do that? Hello? How do I convert a decimal into a percent? I multiply it by 100, or I'm just going to move my decimal place twice to the right. So 0.3 is the same as 30%. Pretty straightforward though, right? We got it? Okay, look at B. Is B going to be growth or decay? It's going to be decay. My B value, which is this entire thing, is going to end up being smaller than 1 because I'm subtracting. So that's decay. The initial value is 55. And then I'm trying to figure out my rate of growth / decay. This is going to be a rate of decay. I look at this number right here. That's my R value, 0.02. Convert that to a percent. What is that as a percent? 2%. Notice this is not going to be a negative percentage, so I should not have a negative in front of there. Any questions on that? Let's do one more, like this. Growth or decay? Decay, it's subtraction here. It's going to be smaller than 1. Initial value. 5,575. And then what is my rate of decay? 44%. I take this number, I transfer it into a percentage. Any questions on that part? Still pretty straightforward? I'm going to switch it up on you just a little bit here. Take a look at D. Growth or decay here? Growth, it's bigger than 1. My initial value, 2,250. And then what is my rate of growth or decay? Jaden? 5%. Why isn't it 1.05%? Exactly. It's basically written as this is my B value right here. But remember, we're not asking about the B value, we're asking about the R value. To find the R value, it's always like the distance away from 1. So this is like 1 plus 0.05. 0.05 is the rate. So my rate is 0.05. Oops. I need to erase this. So that means my percent is 5%. Does that make sense what I'm saying here? This is like a weird, tricky thing. It gets worse when we do subtraction, so let's pay close attention here. Growth or decay? Decay because it's smaller than 1. Initial value, 1,220. Then what is the rate here? It is not 32%. I was hoping somebody would say 32%. It is not 32% because, again, we have to relate this back to the 1 minus R. If I think about what 1 minus R is, it's going to get me that B value 32. What am I actually subtracting? What is R? 0.68. So my R value is 0.68. It is not 0.32. That is the one weird thing we have to pay attention to when we are doing it in this form, and they've squished them together. It's not 1 minus 0.68. So my rate is 68%. Good? Okay, that's weird. I'm going to be looking out for it. You're going to make mistakes on that part. Please just be very careful. Okay, last one. F, growth or decay? Initial value. And then what's my rate? 12%. Again, paying attention. 1 plus 0.12. My R value should be 0.12. I'm not going to say you should never have like a number higher than 100% because you might. Your growth / decay factor might be like 2.03 and then you've got 103%. That's okay. But we got to pay attention. We're adding that 1 to it. Okay, we can just rapid fire these. Letter A, growth or decay? Letter B, growth or decay? Letter C? Beautiful. And we're done. Any questions?